Hey guys, another video today about a new topic that's going to become very relevant as Godot 4.4 is released, and that's typed arrays and typed dictionaries. The reason this will become really relevant is because typed dictionaries is actually introduced in an upcoming version 4.4, so there'll be a renewed spotlight on statically typed data structures. So if you're not aware, static typing is still an optional part of Godot. So Godot is a gradually typed language, which means you could completely leave out the type signatures from your definitions and your method signatures, and the language will decide at runtime how to treat objects. Well, this creates a bit of overhead if you're not aware, and by explicitly typing arrays and now dictionaries, you'll find a very significant performance improvement. So this video is going to go over some benchmarks, and it's heavily inspired by this blog post I found below. So please check that out, because that author actually did most of the legwork, and I'm just reproducing most of his work and then expanding on it with the new typed dictionaries. So it's almost always better to type your data structures. If you know at compile time what a type will always be, there's almost no reason to leave that out. And same with method signatures. If you know that, like a method is designed to return a bool, by explicitly giving a return type as bool rather than leaving it off, you will be creating a speed and performance increase. One hint I would give is always turn on this one setting I found. Settings, text editor, code completion, add type hints on. So what that does is when you override built-in methods, generally these are the methods that have underscores at the start, the language knows what those return types are. This will automatically insert those return types for you. So here's how we're going to profile the performance of typed and untyped operations in Godot. So I've defined 100 million as an integer and as an untyped variable, which is set to be 100 million. And then this is actually a gut test. Gut is a unit testing framework for Godot. I plan to make a video on this later, so suffice it to say, each one of these functions will run in isolation, and there's some boilerplate around the operation I'm doing for each test that basically just times the test. So gut will do a nice job of giving us the output at the end, so we could see in millisecond or second terms how long each one of these tests actually take. So I've broken the tests into pairs. Each pair compares an untyped versus a typed version of the exact same test. So as an example, test addition for 100 million, we're going to add 1 to x. So we're going to increment x 100 million times. In this case, x is just set to 0, and we add 1, whereas below, x is set to, it's statically typed as an integer, and then we add another integer. All right, so we're going to be able to time the difference between these almost identical operations. Also, the loop itself is also an untyped 100 million and a typed 100 million, just in case that makes a difference. Same thing for multiplication. We're going to go 100 million times and multiply, in this case, x by x. And here's the typed version. We're going to do the same for vectors. We're going to add vectors. We're going to multiply vectors together. And we're going to also get the distance between two vectors. Next, we're going to time arrays. So for this, we have a untyped array, and 100 million times we're going to append this index, and then likewise its sibling test here. We're going to do the same thing with a typed array, 100 million times. The dictionary one's a little more complicated. For 100 million times, we're going to set the dictionary. This is going to be a string dictionary, and then we're going to retrieve the value from that string dictionary. So this is an untyped dictionary, and this is the typed variation. So let's take a look at the results now. So here are the results. So I've laid out the first two results, the first two pairs. The top is the addition and the bottom is the multiplication. You'll see about a 15% decrease in the amount of time it takes to do these operations 100 million times. When it comes to the next set of results, when it comes to vector addition, multiplication, and distance, you see about the same results for multiplication and addition, which are very simple operations, but when something more complex like distance between two vectors is measured, you actually see a giant decrease. If you look closely, it's 4.5 seconds is the untyped, 2.6 seconds. So it's a 41% decrease in performance, or increase in performance, I should say. And finally, the array and dictionary results. Still some pretty good jumps in performance, especially for just typing the variables you're going to use anyways. And here are the results for arrays and dictionaries. Also some pretty good performance increases for some minimal effort. So we've looked over some metrics. There's one final topic that's tangentially related to this, and that's packed arrays. Packed arrays are not typed arrays, really. They are bespoke implementation of array that limit it to very specific structures, namely bytes, colors, floats, integers, strings, and vectors. So you can only use them for those types. So there's like a packed colors array, for instance. And the reason you use this is not only are you going to have a speed performance increase, but this actually will give you a memory usage improvement. So the hierarchy of speed, and that's this first point, is that packed is actually better than typed, whereas memory, packed is better than both typed and untyped together, because typed and untyped, it's just how you reference it. It's not taking up any less memory, so they're actually the same from a memory footprint point of view. The downside of using packed arrays is it's missing some convenience functions, and it's limited to a very specific subset of types that can be used. So keep that in mind. There's also a third option outside of typed and untyped collections. Well, I hope you liked this video. Hope it was helpful. I found this topic really interesting. Like and subscribe, and I'll see you next time.